Good morning, good afternoon, actually, everyone. Thanks for coming here. My name is Stefano Trabucchi. I am an Innovation Center Engineer at Epta. And today, I'm going to present you the Switch on Pack platform. It's a new digital platform and solution for refrigeration packs from Eptaservice. So today, SCADA systems are used to control and monitor the functioning of all the single devices that are installed in a supermarket, from cabinets to cold rooms to pack controller. Regardless the electronic brand of the controller, the system is made of the following pieces. We have a supervisor, which acts as a master of the system. And then we have all the slaves from the medium temperature cabinets, low temperature cabinets, cold rooms, the pack driver with the pack controller with the valve drivers, and in case of Epta, of course, our proprietary technologies like FTE or ETE. However, this architecture has some limits. First of all, this system is mostly focused on basic refrigeration, meaning that the aim of this system is to keep the system up and running, but without detailed description of what is going on. The alarms that are triggered within these systems are generic, meaning that they are just telling you we have a problem, a generic problem with a certain component or even with a portion of the whole system. So they are not giving any indication about the root cause of a certain problem. And following, they are not giving any guidelines or hint about how to solve that problem. So given these limits, we as OEM, we asked ourselves, how could we deliver our know-how to field technicians to offer them troubleshooting and system effective monitoring? And the answer is pretty straightforward. We have to harvest all the data that are already available within the pack to create new digital services. Today, in the systems that we are designing and producing, there are some components that are not talking, they are not sending any data to a supervisor system. We can name the gas cooler fans, the oil injectors, the inverters. They are mostly devices that have already a Modbus communication port, for instance, but that we do not use. So the idea is to somehow connect also those devices to collect the data that they are generating. Starting from this background, we conceived the Switch on Pack platform. Its core is made of an IoT-ready PLC that create links between, as I said, devices that are able already to create data and to communicate them through communication protocols. So again, the driver of the pack controller, the gas cooler fans, oil injection, and inverters. The solution is meant for technicians, so for people in the field, so that the interface of this platform is user-friendly and quite intuitive for these guys. This solution works in parallel to the existing controlling system, meaning that this PLC is not interacting anyhow with the basic controller. So we have the basic controller taking care of basic refrigeration. And then in parallel, we can install this platform. We have also the possibility to communicate and to send data to cloud-based services through MQTT protocol. Last but not least, the most important thing to highlight here is the fact that it is an expandable platform, meaning that we can basically add everything that we want into this platform quite easily. Devices, algorithms, features, different features, whatever. We are the owner of the PLC. We can do all this job quite easily. What about the hardware? So what physically means to have this platform installed in your store? We will create this so-called Eco2 ready to connect. So all our packs will have the pack controller, the inverters, and the oil injectors already wired, cabled from the factory, so that there will be only a single connection port on the electrical board, so that you need to put only one wire to connect all those devices together with the gas cooler fans to the PLC. And then to the outer world. The PLC is able to communicate to the store supervisor one way, the other one through a dedicated IP. So the PLC is a web server that is showing you some nice and quite clear web pages where all the information are graphically showed to the user. As I said, first connection to the store supervisor. The idea here is to give visibility to the component. Since the current supervisors are the normal way of interaction with the system for the technicians, adding a device on the supervisor means to add another model, and so to allow the user of the system manager of the supervisor to detect that there is a problem coming from the PLC. And then, most importantly, we have dedicated web pages where basically, as I will show you now, you have a lot of nice and interesting features. First of all, you have a login page. You can enter your credentials. So it is possible to create different levels of authentications, like administrator or technicians, or as many as you want. You enter your credentials, and then you land on this dashboard. Here you see kind of a cockpit of the whole plant. So you have information regarding pressures on the right. You have information regarding temperatures and evaporating temperatures, opening of the valves, and also a very nice estimation of cooling capacity and power consumption of the whole compressors. Let's make an example. Let's imagine that there is a problem with one of the compressor at the medium temperature level. On the system, on this dashboard, you will see that a red squared blinking square in that area. So also visually, the user can understand that there is a problem over there. You click on that area and you will land on a specific page that is showing you live information from the devices connected. In this case, the medium temperature inverter with its functioning parameters like the frequency of the inverter, all the electrical parameters, and the power consumed by the inverter, by the first compressor of medium temperature. I said there is a problem with one of the compressor. Here you see the first one is fine, green lamp, everything is okay. The second one, there is a red lamp saying that there is a problem with this compressor. And if you visually check here, you will see that there is a red lamp on close to the picture of the oil injector. So the problem is not the inverter, is the oil injector. So it's not only a generic alarm, it's an alarm that is telling you that the problem is related to the oil injector. And of course, the thermal protector lamp is off, so there aren't any problem there. If you click here, so on the specific compressor that has a problem, you will land here and you will see even more detailed information about that specific compressor. In this case, you are seeing the total functioning time of that compressor, the daily functioning time, so today how many hours it ran, the number of injection of that specific compressor, and then since we are merging somehow variables from different devices, so the pack controller and the oil injector in this case, we can create new KPIs that can tell you more detailed information about the status of the compressor. For instance, here you can see the number of start and stops of the compressor of this specific day, hour by hour. And close by, you have the same graph showing you the number of injection per hour of that compressor. Here you see 0. Probably the system was running in subcritical. So usually in subcritical, the consumption of oil is quite low, so no injection. So everything should be fine. But here, the point is we are merging data from different devices with this digital platform. There is an alarms overview. So a web page where you can find all the information regarding the alarms, the ones that are currently active, alarm or warning. In this case, there was an alarm from the thermal protector of the compressor of ET, because those screenshots were from the from a layout where an ET was installed. And for instance, communication error on that oil injector, meaning that the system was not able to communicate through Modbus with that system. So alarms and warning that are telling you specific information regarding the status of the system. And also, of course, you can show historical data and check what happened in the past. New feature, advanced diagnostic. The idea here is to create simple algorithms that can trigger specific alarms and can foresee problems that can happen in the future. In this case, the first algorithm that is showed in this picture, the lines that you see here are the integral error of set point minus process variable of flash gas valve and gas cooler valve. The gas cooler valve and transcritical valve is controlling the gas cooler pressure. Gas cooler pressure is related to efficiency of the system. So if we can say that the real variables, the process variable that we are measuring, the real gas cooler pressure is close to its set point, we can say that we have a good control quality. So we are ensuring maximum efficiency of the system. If that's not the case, then probably we have a problem. So a problem could be one of the pressure probe broken, or a valve broken, or something related to the valve. So it's kind of a check if we are working on the optimized curve regarding the COP. Another example of algorithm, the calculation over a certain amount of time, in this case, couple of hours, about the maximum minus minimum opening of the valve. If this value is higher than a certain threshold, in this case 40% and another limit of 70%, then a specific warning or alarm is triggered, saying we have these valves that are oscillating too much. Probably there is something wrong in a certain part of the system. So this is something that is really new, but I think really useful. In other words, we are trying to catch out of trend values, okay? So we can check if a certain value is not close to the expected one. So far, what I said, we can see which is the device that is giving you the error, some advanced diagnostic that is making some calculations to create alarms that are related to broken parts or something like this. Now that we have a problem, how do we solve it? And the answer is in the guided troubleshooting tools. So basically, on the pack overview page, there is a button on the bottom left side of the view. If you click on it, you will open this small dialog box where you can select which procedure, this troubleshooting guide you want to explore. Let's say that one of the algorithms that I showed you are saying we have a problem with the high pressure valve. You click on this button, high pressure valve, and you will land here where you are guided through different questions and answers that you can follow and arrive to the potential solution of the problem with live data from the pack. So also this is quite innovative. We have an interactive guide troubleshooting tool with live data from the pack. Quite innovative. Last, energy consumption. So there is a specific dashboard where is reported the energy consumption of the refrigeration pack. It is estimated only with the few data that are needed to make all the calculations, basically temperature and pressures from the pack controller and the model of the compressors. So we have a pretty precise estimation of consumption and cooling capacity given in real time. The same goes for the live hours and the overall pack live data. So here are reported data from the day one the PLC was installed into the store. As I said, there are very few parameters that are needed to configure this product. Basically, the brands of the electronics and of the fans, of the oil injector, and the models of the compressors. That's it. With these few information, we can do all the things that I showed you so far. So in conclusion, we developed a new digital product called the Switch on Pack solution. This solution collects, merges, and analyzes data from the whole refrigeration pack. We are harvesting and collecting data from all the devices installed within the system. The connectivity of this solution is with the supervisor, but most importantly, with web pages and potentially with cloud-based services through MQTT protocols. On this platform, we are enabling digital services for customers and field technicians like advanced diagnostic and interactive troubleshooting, answer question yes or no, going to the solution of a certain problem. This system, as you've seen, is easy to install. It's very few cables that needs to be connected, and easy to use and also to maintain. It is an expandable platform, meaning that we can add different devices if in the future we will have a new and super smart liquid sensor, level sensor, pressure switch. If they can talk in Modbus protocol, then they can be connected and give more information, more data to the PLC and create new algorithms, new troubleshooting tools, whatever. This is only the first step. Last very important information is that this system is compatible with all Epta refrigeration pack. So compatible with Eco Small, Eco Middle, Eco Large, whatever. The system works with all this kind of product. So thank you very much. If you want further details, please come to our hall, our stand, hall number 7, stand 332. Feel free to come there for further questions and information. Thank you very much.